Because you can operate a machine with a program. And if you don't understand the program, you don't have to. You just know that a program gives us a sequence that can open and close switches. You hear me say that all the time, don't you? With all of this, click, click, ding, what are the switches doing? Open and close. After all of this, sometime I say, so why did you make me spend that much money to open and close this switch? You could have done it like this. Well, that's old fashioned. It worked. It still works. But if you don't make money, that's leaving the market, right? So I didn't need seat warmers in my car. I didn't need vibration in my bed. I didn't need my bed to go, I didn't need my bed to do that. I don't need a television on my refrigerator. But people get it, don't they? Because electronics sells. They get it. You don't have to understand how a telephone works, but if you push a number on your phone, it's connecting circuits just like this board. I'm going somewhere with this. It goes somewhere on this board. Because all we do with switches is what? And we open and close a switch that leads us to what? Something that moves. Something that moves has to be a load. All loads don't have to be high voltage. There's some milliamps. There's some microamps. We have electronic grid circuits that are switches, electronic switches that are not physical switches. We have diodes and diodes and capacitors. And on these boards, whenever you see a capacitor and you see the rings on them with different colors, you look at the capacitor legend and it will let us know what the resistance level of that resistance is by the color of the ring. So we don't color that a lot. I'm just dropping that on you. We, through electronics, got rid of miles and miles of running wire. Wire is hard connection. So why, it's no wire. I told you our phone had a cord on it, didn't it? You could walk through the house like this and then go, whoop, because it only was 15 feet long. So digital operations along with controllers, signals, can allow us to make connections through a signal or electronic, so to speak, switch. There is no cord to your cell phone. You can call anywhere in the world, anywhere, and speak clear. Their signals and satellites took place because, tell my age, but I remember when the first satellite went into space, the Sputnik, and Senator Glenn, who was a senator after the first man that went into space. And so all of this is in my generation, along with how you can fly in a jet, where you can go in a jet, how they don't have to fuel to go from New York City to LA. Those old planes had to stop about 6 times in order to keep fuel. They take off, they're gone. Once you get to California or New York, anybody that comes from somewhere else, you go anywhere to work. Once you get to California, New York, you go anywhere in the world. Non-stop. You probably, in some places, going to Africa or some other place in that area, you're going to stop at Switzerland, Vancouver. And then you'll take a plane wherever else you're going. You can go anywhere in the world. Doctors have changed. How you get needles. So I'm going to talk about this change in what we do. That the first needles that we had were about that big. Ooh, nice crack. She take me to the doctor that big needle. The body of it was big as this. My mother said, be my big boy. And so then I acted such a fool that the doctor said, I'll give you $1. Then I know I like money. I said, I'll take that $1. And so I took the shot again. So 3 months later, here's how change goes. His needle looked like the needles that you have now. It was real thin. And I was like, and he said, it's over. You don't get $1. So things change, and now they're like this, micros. Can't even feel them. People that are diabetics take those needles used to be like that. And sticking it in your arms, sticking it in your stomach, sticking it in your thighs, and it's like that. So
even that thing in and out now, it's retracting right now.
everything is like that now. You can start your car by being in the house, right? That was one of the first digital that came from being a distance and showing how signals work. Because I was like, did it? You know how long that been out? 76. Chevy Vega had one. Because a friend had one with a Chevy Vega, it was orange. Friend girl of mine, we was friends. We been friends since we were young. And she said, I'm gonna start the car. I said, I'll go start it for you. She said, digital. If you get locked out of your car now, what they gonna do? Do they have to come out here with a key? Do they have to stick that slider in there?
No. It's a signal. The phone, you can use the phone.
I got locked in out of my car, running my mouth, and I shut the door. So, man, I called the insurance company. She said, we'll call somebody. He called me, and he knew the address, because I guess I told the insurance company, and she told me. And he came out there, and I was like, I had a new car. I said, man, let me stick that thing down in my door. It probably never worked, man. These scratches on my windows. He looked at the VIN number. I said, beep, beep, beep. And my car said, click, click. I said, oh, shoot. These better not get that. He said, oh, you get 15 years for getting caught with this. And so the other half is, how does that work in business? And I'm gonna show you how it works in ours. There's a lady at church that couldn't get her car started. I don't know why they think I know how to do it. I don't know car. And I went and said, I said, don't sound like it's getting gas. So she calls, because she had bought it 2 weeks ago. Man said, you didn't pay your bill. I didn't know they could do this, did you?
Yeah.
That's in y'all generation, because y'all don't pay your bill, so I pay mine. And I took her to the car dealership. She paid her bill. When she came back, it said, zoom. They said it'll be on there till you make the final payment. So digital circuitry is used in business, is used in our industry over the last probably 15 years, has increased probably 80%. You won't see a lot of this anymore. You won't see a lot of standard wall thermostats. Even the ones that are standard have digital circuitry inside, because it has a digital LED display. What's an LED?
Light emitting diode.
That's exactly what it is. It's a light emitting diode. One of the circuits we talked about with diex and triax and bridge circuits. And there's an LED. And we use LEDs for what? Because, here you go. This is the other thing about digital circuitry. Because all of these components are part of this circuit, you cannot put your meter anywhere on this board. You can only put your meter on the analog side. Inputs. They are marked clearly for you, right? You know them? Did you know that? You didn't know they was marked clearly? No? Did you? Okay, so if you look like in the electrical lab, where you have spade clips, that's where we connect. You'll see that you also have something familiar that you see in lab. That's why we put those connecting bars in your lab, because these are all the way there. Tell me on the connecting bar, what are the wire color, what is the letters on there? You call that? I don't know. What's the letter connections on it?
W, R, G.
So what does W stand for? And we're gonna drill this because you need to know it. What does W stand for?
Heat.
Heat. In regular heating and air conditioning. What does Y stand for?
Cooling.
Where does the Y connection go after it's tied to that connection on the furnace? Where?
To the fan.
What fan?
Cooling fan.
Y goes to the cooling fan? Look at the board again. Low voltage. How does the furnace blower fan initiate? What voltage?
24 volts.
It's 24 volts, and for the relay to be initiated, then the relay is dealing with what we said yesterday, a coil. Because anytime you apply voltage to a component, it has to have a coil in order to have action or movement. Whenever you think of 24 volts going to a relay, 24 volts going to a contactor, 24 volts going to a limit switch safety circuit, 90-80% furnace, pressure switch, low voltage 24 going through this switch. It is a safety switch circuit. This is a switch. What did we say is the difference between a switch and a coil device, like a contactor or a relay?
One of the contact, you take more right there.
It consumes
More
resistance.
volts.
That's,
Consumes power.
the contactor takes more voltage. Both of these, all three of these are 24 volt components. This one is one that moves because it has a coil. Anytime we have a coil, it tells us that there's gonna be motion, action, and movement from that device. Whether it is a contactor, whether it is a valve, whether it is a relay, there is movement. A motor has coil, there is movement and magnetism. But that's what the device operates from. But how do we get the voltage to the device? Often it's by a relay or a coil. A relay or, a contactor. Because a contactor, we said, is a two-part component. What are the two parts to a contactor, generally speaking? Name me something about it that you know.
L1, C1.
L1 and T1, and then what else?
The L2 and T2.
And T2. So power comes in on what?
L1 and L2.
Okay, so there, or voltage. So therefore, what does T1 and T2 go to? Huh?
No, to the.
some
loads.
To something that is a load. A load. But how does it get there? Because T1 and T2, or L1 and L2 are still here. We're getting back to the low voltage. How does the power from, or the voltage from L1 to L2 transfer to T1 and T2?
Magnetic.
The magnetic
Solenoid.
does what?
It create a magnetic field
And what happens?
it push that button.
Close the contact.
Close contact.
It pulls the contactor the way this system is designed. It pulls the contactor in. When the contactor is pulled in, what occurs?
is able to pass the voltage
Yeah.
through to T1
No
to T2.
resistance.
Voltage goes through. Voltage goes through. L1, L2, T1, T2. Because we said that the whole purpose of learning components is mastering every aspect of a component so we can learn how to read wiring diagrams based on the function of a component and where it is placed within a system and how it functions. It has a coil, it's magnetic, you're right, it creates magnetism, it pulls in, which is an action and a movement. When it does, it's simply what? What is this
Where's the
anyway?
solenoid on that?
Solenoid?
That wire right there.
That wire, it's not a solenoid, it's a coil. Solenoid is a little different. But solenoids create magnetism as well on a different component. However, a contactor and a relay is still only what? A switch. But when we started off talking about digital display and digital movement and distant control, because I can from a satellite if I have more money. A lot of places in Europe don't have towers, they have satellites. We can communicate back and forth. Your cell phone is wireless. This system here by itself is analog. And it has we call it hard wire, because there's wires connected. But one interesting thing about it is, do you understand that? If you don't, say something.
About hardwire?
Hard wire, coil, magnetism, L1, L2, T1, T2, and the purpose of closing the switch is to take L1 and L2 voltage power source and move it on to a component that moves. Yes.
They call it T1, T2.
L1 and L2, we call it a load. T1 and T2, I tell students, for easy memory, to something else. That's how you remember. It's to another component. To the component that we want to energize and run. It really wouldn't matter if you turn it upside down, would it? Same thing. Same thing.
And what's the difference between the basic difference between the two things you got in here, the relay and
This?
yeah, that and the one.
This?
Yeah.
That's the pressure.
One's a pressure.
Okay, so that's part of what we learned, the difference between, this isn't a relay, it is what?
Contactor.
It's a contactor. What's the difference?
The voltage and.
It's beefier. It can handle more voltage. Relays are using 28 to 30 milliamps. This is a action switch because we have to have 24 volts applied to this switch in order to close it. That is a power what?
Power consuming.
Power consuming. And it's something special about power consuming is that you can't take a power consuming device and take L1, neutral, L1 and L2 and do this. Why? Not across this switch. Why?
Because the power already in.
Because of the trip and it doesn't have opposition to the flow. You have to have the positive and negative. You have to have a power consuming device to put that voltage to a motor. You have to have a coil, because the coil has resistance and we can apply. Is this 115 or 120, L1 neutral. If it's over there, it could be 208, 230, 240. You look in disbelief. What's the question?
No, this.
This doesn't have, and we have to make sure we get this before we move on. This is a what kind of switch? This is power consuming. What is this one? We said pass what? Pass through. This is a pass-through switch. What does that mean? The voltage is not consumed by a load device.
Just a switch.
It's merely a switch. So the difference between this is a safety switch that breaks low voltage, in this case in our furnaces, of 24 volts. It's a safety device, right? So R goes in, R goes out. This is a, what kind of switch? What other kind of switch is, how does it work? Huh? Temperature. It's a thermal switch. So that's the safety part of this switch. It's a thermal switch on a furnace that prevents overheating in that part of the furnace. You can have several of these to sense heat in several areas, but they have the same function to prevent overheating. If overheating occurs, it could be danger, it could be fire, it could be anything else. So this switch opens. When this switch opens, it only separates 24 volts. That's it. It opens 24 volts. It's not consuming anything. But to make it a little more complex, if we have 24 volts going across a switch, a pass-through switch, it has to be going to a what? A load. So if it's just a pass-through switch, you can follow it to a load. Because if it's a safety switch, it's going to a load. The load on a gas furnace could be what? Some of the loads we have in 24 volt.
Light bulb? I don't understand.
Can you say that again?
Yeah, I don't understand.
Gas valve, which is W, it's light bulb on that board. It could be in a limit of this type. It could be in any control. What do we want a safety switch to ultimately do?
To cut the circuit, yeah.
De-energize a circuit. So in other words, if we had a L1 of 24 volts on a heating system, what would be some of the safeties in there?
Pressure switch.
Huh?
Thermal switch.
It could be a bimetal. So we talked about symbols. I put a bimetal in there with a symbol. You can look in your book while we're doing this.
You got on to me for this one.
Huh?
You got on to me for this one.
You go to what you think it is up there. I'm not gonna skip you because you sit in the back of the room.
That's open. That's open. The first time. Yeah.
But they got something else.
The line.
Two
circles, and two dots.
Two dots on the bottom.
Is that it?
Those
Give us some help.
There's
Give
one
us some
line.
help.
little dots gotta connect to
Because we're ultimately, all of this conversation about components is gonna lead us to understanding how to draw wiring diagrams and how to read wiring diagrams. And it's two dissimilar, thank you, it's two dissimilar metals. So the metals flex and change according to heat. Where does the heat come from?
Or the heat. Gas.
Not gas valve. The gas valve is part of the three parts of combustion.
Gas, air.
Burner.
and-
The burner?
Yes, a burner.
Fuel. Well, fuel, air, and what?
That the leak up on?
What's, for heat, what's the three components? For fire?
Oxygen. Oxygen, fuel,
Ignite.
And igniter. And that's it. Okay, so, one thing that we're gonna learn by starting off these drawings is that, which is kind of, I'm thinking about a way to put it to you, so it becomes simple, is that when we first looked at a wiring diagram, we noticed that often it's separated in two parts, is it? And so, show me the two parts, what it looks like to you. You have a top part and a bottom part to a drawing. This is how you're gonna learn this. It's a difficult concept for some people.
I know the bottom part has like switches on, off, fan.
Okay, you don't have to put anything in there yet. First, we wanna know, that's your bottom part, this is your top part. What is the difference?
One's a high voltage side and one's a low voltage side.
This side is what?
High voltage.
40, 120.
It could be, or it could be, in your case for some of these furnaces, it could be 120 volts. Make it simple at first. So when you have a drawing like this, it's gonna separate that everything we draw that takes line voltage will be represented on that drawing at the top. This symbol represents what?
Secondary.
Transformer. It represents a transformer, which separates this side from this side. That is the transformer that you wire in the lab. And so we know then that if we look at a drawing, a mechanical drawing, electrical drawing, that the lower part, if we see that bar and 24 volts, the lower part of that drawing is 24 volt components or coils. And you can have a seat, thank you. And the part that makes it somewhat strange to look at times is because we're not understanding quite, we're gonna be drawing these two, where the placement of components go. So by understanding the basic components, what 24 volt component would be down here? Stack, for one, you're right. Not putting wires to them yet. What else?
Relay.
Any relay. So it could be shown as this, right? Fan, relay. Right? What else? What else is 24 volts down there? Pressure switch is in 24 volt cycle. What else?
High pressure, low pressure switch.
How does the compressor energize? Not a relay. Contactor. So you probably would have a compressor, what? Relay? Part of that, 24 volts right here. It could be called the relay part of it here. You'll see the same device up here, but now it's talking about what? Compressor contactor. It's talking about L1, L2, T1, T2. So sometimes that's what gets confusing when you first start trying to understand wiring diagrams. You're like, well, why is that up there and why is this down here? It says contactor, but up here it might say, and that's referring to L1, L2. This is referring to coil voltage of 24 volts that comes in and causes it to close. So how does that help us? How in the world could that help us troubleshoot? With all of this electronics and all of these devices, how does that help us troubleshoot?
Because we can isolate the component, whatever component's not working to whatever side, depending on if we're working from the low voltage side, or the high voltage, we just can isolate
Or
whatever.
what it looks like. And you're correct. We can, by understanding how this works, go to the drawing, understand how it's placed by what it is on a drawing, determine where to look. Troubleshooting is, I know my components, how they work. I know how they function, the voltage, input and output, control voltage. I know the safeties that are in line with R. They're in line with R. So therefore, you may have several choices of in line with R, but you will learn that there are other visuals that we pay attention to as well. So if, for instance, this contactor closes, but nothing runs outside, what is the problem?
No, you said nothing wrong, sir.
Nothing is running, but the contactor is pulled in.
It's closed, but nothing is running.
Nothing is running.
There is no 240
Oh, the
volts.
power.
Switch is not.
Main power.
There's no line voltage.
There's no 240.
Where would you check to see if there was line voltage?
L1 and L2.
Yeah, well,
Okay, so if you don't have voltage at L1 and L2, where you gonna check next?
Service disconnect.
What break?
The service, I'll go to service
Who
disconnect.
said that?
Me.
Service disconnect, then breaker. Now, if I go to L1 and L, huh?
Wait, the service disconnect, you go check that doesn't work, go past.
If I don't have line voltage at that condenser.
Then you go to the breaker?
Yes, because I could have L1 and L2 coming in to the service disconnect. It may even be a breaker in there.
Yeah.
And it could be a fuse, which we hope not, because they're hard to find. And if it blows, we know here, we can reset. But you still have to check the circuit, even if it's a fuse, as to why the power is not going through. So then, if we have L1 and L2, if we have 240 at the service disconnect, then what?
then,
But it's not going to contact L1 and L2, then what?
sorry, what's your question, sir?
If we have line voltage
At
at
L1.
L1 and L2 at the service disconnect, but T1 and T2 coming to the machine has nothing, then what's the problem?
Contact is failed.
If the coil is pulled and there's no power going through.
Let me understand your
You
question
answer.
again. From the disconnect, there is power.
Right at the equipment,
And coming to the contactors
Yes.
point, there is still power.
has no power.
Oh, then if there is no power coming to the contactor point, the problem is between the circuit breaker and
The wire.
this thing, you're gonna check why there is no continuity there.
It's not between the circuit breaker and the disconnect, because it's at the top of L1 and L2 at the disconnect. But it's not at L1 and L2 on the contactor.
It's contact.
That ain't working. You need a better box. Yeah, that box ain't working.
Service disconnect.
Mr. Harris, don't have a marker, but we can't see that right there.
Oh, I thought you had.
Thank you.
Great fish.
Oh, okay.
I wondered, could you? That's so nice. Yes. And it could be, what did you say could be in here? It would be two, wouldn't it? Or if you're, this would probably be a harder one to see than a breaker, right? I try to put breakers in mine because I wanna go click, click, and reset it. But if not, that's even better, it would have to be a fuse. So if that's the case, L1 and L2 is not coming out here, is it? And we said from here, it going, what you was talking about is a compressor contactor, which we were talking about L1, L2, and then T1 and T2 coming out to a machine. So the question was, if we have L1 when we tested it, if we have L1 here and had 240, and we took our meter here and had 240, we know that we don't have to go here, do we? Because the circuit breaker panel feeds the service disconnect. So you were half right. You said the problem is probably between the service switch until you said the breaker.
So,
We have no breaker problem, it's here. These are cartridge fuses.
That's your problem, ain't it?
so
Cartridge
when do you
fuse.
say there is no power now?
It's no power coming out, there's no
Then it's from
voltage.
it's from the contactor. The problem is from the contactor. If it is depressing and it's not passing power, then the problem is the contactor.
Cause it's not at 2-1 and 2-2, 2-1 and 2-2.
T1 and T2 where?
You say it's not
Do we
there.
got like 24?
Show me where the problem is.
It's the fuse thing.
No, Curly, show me where the problem is. Here, everybody participates. A whole lot of people don't know. We're gonna learn together. We're not isolating ourselves. Think about it. This is electrical. We're following and tracing lines. We're trying to learn how to develop an understanding of wiring diagrams. Same thing that I want to impress upon you in that electrical lab. That's why I say, don't take anything off the board. You're just following lines. That's the introduction to reading a wiring diagram. That's what that is. Introduction to how we trace wire to a component. Some are switches, some are power consuming devices. That's what you should be doing. That's how you should be learning this. And the troubleshooting at the end of each unit is saying, if you go to E and B, well, is it open and closed? What's the voltage? What's the amperage? It's showing you how to go on a real system and read voltage without being intimidated like this. That's the beginning of this. So if we have a 240 circuit, this is the service disconnect. Do you even know what a service disconnect is? You might not, do you? Okay, that's a good answer. I want you to say what you don't know. The service disconnect is the connection from the breaker That's the condenser. By code, you must have a service disconnect within, you usually 5 to 6 feet from the equipment for service. Service disconnect gets its voltage from the breaker, often called the load center. You guys call it the breaker box, that's what I call it since you was a child. It's a load center. Now this might make sense since we talked about loads. Why do they call it a load center? Because everything you plug in the wall, from a lamp to a television to a mixer to an air fryer, is a load. That's why it is a load center. Every load in your house goes to the breaker, and it has to be accountable to the maximum load on that box. Nobody hit me like that with the boss. She'll be mad. That's her. She the only person who goes back to back. I know it is. I'm going to click it. Okay. Breaker is what? Main what? Power. Feeds a load. This is service disconnect.
It's a big switch on the side of the house.
What does service disconnect do?
Breaks the power.
Turn the power off to get the instant.
Disrupts the power. To a load.
It's a manual switch.
So it is a manual switch. And it goes to what?
Yes.
Compressor contact, which we were discussing here. So L1, L2 come here to L1 and L2. We said we have voltage on L1 and L2 from the service disconnect. So if we have L1 and L2 240, we don't need to go back to the breaker, because that's where that 240 came from. We're good. What we said is we don't have low voltage on T1 to speak and T2, and in this particular case, you have two fuses. You have to have one on L1 and L2. So we're not getting it because you, my friend, said something I hate text to do. And you made a visual of it. I pushed it down and it didn't come on. I'll stick my finger in no voltage. And here's the issue. That's done a lot. So I'm not beating you up, because a lot of them students call me that are graduates. They say, it don't come on when I turn it on. You don't know how many times I hear it. But when I push it in, it comes on. I said, so what's the problem? Because all we're talking about is control voltage and line voltage. So if it comes on when you push it in, which you shouldn't be with your finger, do I have a line voltage problem?
No.
No.
What kind of problem do I have?
You have a the
I don't want to see all of that Michelangelo shit.
If you push it on manually, it comes on.
You have a line, not a line voltage problem if you push it in and it comes on.
Yeah, then you have the problem
You have
with
a
the 24
What's the
volts
right
relay.
verbiage?
You have a mechanical problem.
No, it is the
How do you have a mechanical problem? If you could explain to me how you do that,
24
you
volts
might
that
be-
comes to the relay.
How could you have a mechanical problem? Because I don't know how you process, you could be half right. If you mean you could have a mechanical problem because this contactor must move mechanically before it energizes, you'll be half right. My question is, because we're talking about line voltage, supply voltage, control voltage, and low voltage, if you push this contactor in, which you shouldn't, and and it does what? It energizes the machine. There is no line voltage problem. We're trying to separate. We've been talking about control voltage for 2 days. Remember, we said that troubleshooting is understanding how each component functions. How does this function? It's simple, you know it. How does it function?
The switch goes down and passes the load.
How? By itself? By invitation? How does it close?
With the bimetal.
Ain't no bimetal in there.
Coil.
If it has a coil,
We have a coil.
it's going to a load, and it needs what in order to magnetize and pull in?
24 volts.
This is a common rookie overshoot. Like you told me, the contactor was bad. First of all, it's not bad, it fails. And you can't say a contactor has failed unless you do what? How do you know a contactor failed? How can you call it dead? How? No, he gonna answer that. Just because you look nice, that don't mean you're gonna get by. How did everybody participate? Tell me what you know about it.
There's no current run through
It has to have voltage go through here. What type of voltage? How much? It could be a supply voltage of what? Name the voltage number.
24 volts.
24 volts. So you can say supply voltage of 24 volts, because it is a supply voltage of 24 volts. You can say that. I know you back there. Do you get the concept? So why did the machine not run by the control? These are controls. If we don't have controls, you know what he did to control his air conditioning? It's fixed. It's running. You're gonna stay there for 24/7, 7 days a week. That's why we have controls to automation, automatically open and close switches. So why did this switch not close in this particular situation?
It didn't receive 24 volts from the transformer.
In his situation, it didn't receive 24 volts. How would you approach that? See, this is what troubleshooting is, and that's why you have to have the knowledge of components. How would you approach not having 24 volts here? Where would you go?
You go back to the control bus, where you have the 24
I told you
volts
quit
coming-
drawing.
Hmm?
Quit drawing me stuff.
If the 24 volts doesn't come there, you know, when you read it, you don't get 24 volts.
So tell me on the control board, where is this control board you talking about located?
The one inside units,
Where you?
it can be on that board of the Phonex board.
What's that furnace board called? What's it called?
That way you have the evaporator on the furnace is down, the evaporator is up. There is a control unit there.
I'm not talking about mechanical refrigeration. I said, where would you find 24 volts? We're talking electrical.
It's from the transformer first.
On your low voltage, you're talking about
It comes from
the
the
low
trans-
voltage side. On your
I thought, sir, I thought that we just said everything labeled on here is where we could test. Did we say that?
Is it not the control box?
If it's an R and a C, what would I expect to be on there?
It's 24 volts.
Will we get R and C if we took the door off? We would read R and C would give us 24 volts? Huh?
Yeah.
If you take out the what?
You heard what I
Our
said. If we take the cover off the fan motor,
It's cut off.
okay, would we have 24 volts? No. We wouldn't have 24 volts to R and C because why?
That switch has cut off.
The fan door has a safety switch that opens when you take the bottom door off, so you don't get injured. And have your hand go around, tear it up. So you see how this voltage is moving in. If you don't have voltage on the fan switch, it doesn't go here. There's no L1 and on here, no L1. That's the safety switch.
I'm confused now.
Who said it? How are you confused?
He's saying, cause we went from talking about why the contactor wasn't
That's right.
power through.
So I asked you,
Now-
go ahead.
I mean, I understand where on the bus board where we're talking about as far as the controls, but I'm not saying, he's talking about fans and taking the thing, it just confused me, like, come on, I'm confused.
Can I help you?
I'm gonna take the door off and stuff.
No, I'm gonna help him out since he's confused and discombobulated. Here's the deal. We talked about following a circuit. We said that the contactor didn't close because this gentleman said he pushed it in and the unit came on. I said, what kind of problem is it? He said it's an electrical problem. What kind of electrical problem? I'm gonna ask you that. It's not a line voltage problem from L1 to L2 to 240. What component? We're talking about how components operate, and that's how we make repairs to mastering how a component operates. So then we said, what makes a contactor operate? What voltage?
24 volts.
So he said it didn't close. So I said, what would you do next? He said, I'd go to the transformer. Well, to get to the transformer, you have to take the furnace door off.
Oh, I didn't hear him say.
So I said, if you had that card, how would you test to see from that point if you had 24 volts? He did answer correctly, but at first he said R and C. I said, if you took the door off, would you get R and C, 24 volts?
No.
And then he said, no. I said, why? Because there's a door switch that supplies 124 volts to that card. If the door switch doesn't have 120 volts, then the transformer doesn't have 124 volts. If we don't have 124 volts on the primary of the transformer, we don't get 24 volts. If we don't have 120, we don't get 24 volts on the secondary of the transformer. So you won't see on the contactor coil 24 volts. But you could have checked it real easy to see if you overall had 24 volts on the system. How would that be? Quick way to check 24 volts. I don't even need a screwdriver.
It's time to fan.
Huh?
Fan.
What about it?
Check, connect, R to,
I don't have to connect nothing. How?
Resistance.
Check the thermostat.
What? What you gonna do? What you gonna do there?
You're gonna jump,
You don't have to jump nothing.
you
What
just
you
turn it
gonna
on,
do?
see if your fan comes on.
Turn the fan on.
Turn it on.
Turn it on.
See if it clicks.
If you put it to manual or fan on, and the fan comes on, what do you know?
You know you got 24 coming out of the.
How do you know you have 24 volts?
Because the thermostat takes 24 volts.
Fan turn on.
And the
Well,
fan.
the relay to the fan, I done told you, but the fan doesn't come on because you have 24 volts. The thermostat transfers 24 volts to what component? How does the fan come on?
Fan relay.
Fan relay,
Fan relay.
because the fan relay takes what?
24 volts.
There you go. That's the only reason the fan came on. So what wires would we jump on the thermostat after you took the cover off to see if the fan works?
RG.
But you didn't have to take it off, right? You could have just checked it at the thermostat. So that's one way that we think out the process of how to determine what has failed. Now to go back to our original, we had, before you brought that in, we had a fuse. Now we said the fuse, we had voltage to L1 and L2 at the service disconnect. We had two fuses in that service disconnect, the kind that I hate because it has fuses. But we didn't have T1 and T2 distributing 240 to the contactor on the condenser, because that voltage goes to the contactor. Everything is connected like on your board. Everything is connected. It's connected. And so the The 240 was not going to the contactor. In this case, the contactor was pulled in and closed, but there was no machine running. It had a call for heat, but nothing was running. So that meant the 24 volt side was good. It was good. But nothing ran on the line 240 side, and it has fuses. What would you check?
Check the fuses.
You would check the fuse. I heard you say, I ignored you. How would you check the fuse, sir? It's easy, and you already know it. You already know it. How would you check the fuse?
Continuity with your.
What would you say? Check. Put your meter on with a fuse.
Resistance, continuity.
First, you.
So if it was open, what would you expect to see?
Oh, 0.
0.
Oh, well.
There won't be any continuity. But first you must off the power. Then you check for continuity between those two poles.
Okay. So you do what? You would have OL, which is
Open
open light,
line,
open lead.
delete.
And so what would you do for the repair?
Stairs. Release the fuse.
They need the key for the cage.
Oh.
Monitor in the house, yeah.
Somebody let all that gas out of one of the heat pumps in that room, and I told Paul, don't let them guys go in there. Don't let them go in there. That ain't their privilege. It proves they don't know. You can have a seat. So ask questions about this so far. Go ahead.
Okay, you said you turn the thermostat on, put on fan. But the fan we're here would be the evaporator fan, not the condenser fan outside. Or inside the house.
No, he said if you was getting voltage coming in, there was no voltage going out.
Yeah, I'm saying 24. Okay, say we get 24.
What
about
I'm gonna tell y'all something. If you're getting, I'm gonna tell
Say
you
that
something.
again, sir.
I just went to a job.
I was just saying, like, you said, you turn the thermostat to fan only. Okay, we hear fan come on, that's the fan and evaporator.
That is true.
How we know that 24 volts making it outside?
We're not talking about outside yet. I see what you're saying.
I thought it was something.
We are. We are. The question is, even if we turn, it's a good question, even if we turn the fan on, put the fan on the thermostat to manual or fan, and the fan comes on, how do we know it's outside? We don't yet. We're not checking whether it's outside at this point. That's a good question. We're checking to see if we have 24 volts, so we don't have to go to a transformer, we don't have to do all that. We do have 24 volts. And so the fan relay, when you put it on fan, causes the fan to initiate and close. If you want to see if you have it outside, for laughs and giggles, this man right here like to take the thermostat cover off. So he took it off again. What wires is he gonna jump for the fan, AC, and condenser? What wires is he gonna jump? What color?
G green.
G,
arrow, and
R,
dot, and
what else?
And Y.
You blew it now. White?
Why? Cool.
White is gas.
Why?
Yes. All day. Somebody give me a different color selection. Yellow. Yellow is what? Cooling.
Okay.
So we're talking about switches open and close. When we jump out terminals, in this case, we are taking all control off the system. We want to see if the system will come on if we energize the correct components. G, R, and yellow. G is the distribution on the furnace fan, right?
Outside is gonna be Y, because Y, color yellow, is an extension of color red when it goes outside. And so red, or which we see is yellow, because when we go outside, we said how many wires go outside?
2.
It's called 2-wire. 2-wire outside, 4 for AC inside. 2 wires always outside. That's a trade calling. So if we jump out R, G, and C, what do we expect to occur?
The compressor will come on, the condenser fan will come on,
Why would it come on?
because we have manually jammed.
There you go again.
Power.
Why will it come
Power
on?
fan.
Why will the condensing fan and the evaporator distribution furnace fan system come on when we jump out? We're not using no thermostat. We took the wires R, G, and Y and twist them together. Troubleshooting is, I know what to expect, but what I expect didn't happen. So what do I look for when that situation occurs? You must know what side, low voltage or line voltage, we're looking at. So when we jumped out R and G, what was our expectation? The fan came on. We said, what do we know? That you have 24 volts. The next thing is, how do we know, according to the question, that we have 24 volts outside to the condenser? How do we know that? That doesn't tell us that. It tells us we have it inside. How do we know that we have it outside?
It's when we jump that R and
You
G.
initiated the cooling, you
So that
when you get cooling?
So what initiated the cooling? What color?
Yellow.
How did it, we still always talk about relays, switches, coils. He told me the compressor came on, but that was out of sequence. The compressor came on because what was energized?
Because of contact.
Because of contact. We're talking about low voltage. Low voltage has nothing to do with powering up the voltage source for a compressor or a condensing fan. It only has to do with the switch closing. They work together. Switch closed, I have L1, L2, T1, T2, everything runs, provided the other components are in great shape, like capacitors. Then the motor will run. Questions? Because that's a difficult part to kind of get. This is how you start off learning how to read drawings. How to troubleshoot.
Question, sir, is that I hope there's a stage where you can take us practically to go and do those things, join them.
A safe way to do what?
I think there will be a
This is a
stage.
lab class that we trying to.
I think there will be a stage where you can take us to physically go and join those wires and see how it works.
Yeah, but you don't take no component off. That would be like taking a motor out of a furnace, seeing if it worked.
No,
Taking
what
the
I'm
compressor out to see
saying,
if it worked.
what I'm saying,
You'll be able to do that in lab,
yes.
to imitate a switch. You become the switch, and it's true. And we take out the automatic switch. We have taken away some of those relays, and they're on the board. So that's why we have to know what terminals we can jump out or bypass to see if certain things are running, and the ones we cannot jump out, and for how long we should do that. Now, the other thing about it is, we so far are talking about controls that have a simple open and close. So far was by temperature, and then we talked last time a little bit about pressure. The only difference is a temperature control opens and closes for a particular purpose on temperature. It could be opening and closing for what? A temperature switch. Open and closing because of what? Temperature switch does not open and close for pressure. A temperature switch opening and closing, the reason is what?
Temperature.
Oh,
Too
much
much
higher.
heat.
Too low temperature, too much.
Oh, the high.
Okay, so you are describing to me how it works. I'm asking you the purpose of it opening and closing. It does open and close on
It let you
temperature.
know when the set temperature is at its
Shut off.
point.
Shut off.
Shut up.
It could be nothing wrong with it. It could be that we are at set point, which I wish this room was.
Oh,
And set point means whatever I set on that thermostat,
It's gonna
when
shut
we
off.
get there, we've done our job, the switch opens. It could be on the other side, which we constantly talk about in all the labs, is this a safety switch, and it can open because something is too hot or pressure is too high.
So you said the temperature is cut on? That's what you-
Temperature is because we are talking about components and how they work. How does the thermostat work? What kind of control is it?
It's a temperature.
What kind? Somebody said it, what?
It's a temperature.
It's a temperature switch. When it reads the temperature on the thermistor that's inside, and you set it higher, the room temperature, then when the running of the machine reaches the temperature that you set, it cycles off. It's done. It did its job. So the temperature lowers.
And then that's why it comes back on.
That's why it comes back on. It's a temperature switch. It's a thermal switch. And you keep raising it up, it's gonna keep coming on. Gonna keep on coming on. Does that make sense?
Yes.
So that's one single part of how it does. So then when we add in the board, we're gonna say that we have switches which do two things.
Open and close, on and off.
Most of the time in our business, controls work mainly 98% four ways. What are they?
Temperature, pressure, timing,
Temperature, pressure, time.
Flow. Flow. Yeah, because I said I'm done.
No, you gave us the four flows. No, I wrote it down.
Okay.
I got the four type of flows.
Well, that's it. Four flows, that's how they operate. And so it's either we talked about water flow, distribution, air flow, then this is how, I'm gonna let you go for a break, and then we'll combine that with how do they work together. So what looks like the problem of contactor is not necessarily the problem. Because when we clicked and found out we had 24 volts, you could have people troubleshoot their own way. If the contactor didn't close, some techs will pull them two wires off and see if they had 24 volts, right there. If they have 24 volts, they're gonna say contact bad. If they don't have 24 volts, I can leave that alone. I put them two wires back, because when I find it, I don't wanna be touching metal and then burn something out. So then we went inside to see if we had 24 volts. So if we have 24 volts inside, meaning the fan is operating, then we need to find out why it didn't reach the outdoors. That's what we were trying to figure out. Sometimes the wires could get nibbled on by varmints and break. Sometimes the varmints can eat the two wire and eat them. I don't know why they like insulation, but they do. Chipmunks, squirrels, rats, they would eat the vinyl off the wire, and when it touched, what's gonna happen? Because that's common and hot. And they would short everything out. And you'll be looking, and you go up under there, say, hey, I can cut these wires, put them back together. You're gonna do it again next year. Same place, I guarantee you. Same place. They're very homebound. Any questions for break? Yes, ma'am.
Well, you said don't touch it with your finger, what would you touch it with?
I really don't like touching them with anything because I'm accustomed of taking my meter and going across the coil. So what would I expect? Remember, we have expectations. That's why we're great troubleshooters, because I expect to have what voltage at that contactor.
24.
If I don't, the problem is not here. So that's why we went to the thermostat and put it on fan. Because when we put the thermostat on fan, what do we expect?
The fan to come on.
If the fan comes on, We have 24 volts in part of this system, so the transformer is not the problem. We have 24 volts. It's not outside. So then we said, well, let's see. Let's take the cover off. So if we take the cover off and we jumped R and G, what is the expectation?
Fan come on.
If we jump R, G, and Y, what is the expectation? So if we twist those three wires and the outdoor unit comes on and the indoor fan is running, what is the problem?
The contactor that you pulled off those 3 wires from.
Ain't no contact the problem because we twisted them wires together. Outside running, inside running. What's the problem? Ain't no relay problem, everything running.
They say that-
Contactor pulled in.
Thermostat needs to be adjusted.
Who said that? It's the thermostat. That's the thermostat test.
Okay.
If it doesn't work when I put it in cooling, but I can take the cover off and jump those wires out, and it runs fine, it's the thermostat. That's why you need to know what a component does, switching, opening, and closing. This is the most
So you've been.
challenging part of learning about how these machines work. This is a challenging part, because you have to know what you expect. You can't expect what you don't know, right? So we have to be in the know, so we know what to expect. And whatever doesn't happen from my expectation, that's when we walk right to it and say, you problem. That's how you fix your problem. Because this should have happened when I twisted R and G, and it didn't. So I don't have 24 volts. So if I twist R and G, and it didn't come on when I put it to manual, I switched R and G together, and the fan didn't come on. Now where am I going? I gotta find 24 volts. Where am I gonna find it? Transformer. I'm either crawling or going in the ceiling. You got 2 places, or the basement or the garage. You gotta find the transformer. And it could be what, a fuse, which is a problem too. Why did that happen? Or it could be a transformer. Whenever that happens for me, I say, why did that happen? Something else is going on. It's probably not too much current. It could have been a storm. It could be that it's wearing out. It could be that some wire is touching somewhere. Some wire is touching. It only takes, if you have stranded wire, you know what stranded wire is? If one of those little hairs touch metal, what happens? It's shorted out. 1 hair is all it takes. 1. All right, take a break.
So you gotta put that wire around those screws tight.
You gotta put everything in there tight. If you don't do it, and it looks like serving spaghetti,
Like 60 something.
it's 60 cents each, but 2 for $1
Whatever tax.
Used to be 4 for a quarter.
No, yeah, we growing 4 for a quarter, dog. I mean, no, yeah, no, 4 for $1, 4 for
It went
$1.
up on everything. It went up on everything. It's like the honeymoon.
Well, the biggest cost pretty much of everything. I'm talking about how generations turn is a car.
It's like that Arizona.
They talk about somebody else on that fly. That decade was already here.
Amen. I know they probably already
You let people fly, they got to go to the damn thing. Engine light on.
Car goes down.
As much for a car as a house note is.
Yes. You said they said?
Your generation, you pay as much for it.
Yeah.
Ain't paying nothing. I paid nothing over $400 for a car. Nothing. Nothing.
You split what?
I ain't
Insurance
paying nothing
included?
over $400 for no car.
Insurance or like?
The car note.
Oh, okay.
And insurance is hard too.
Nah, but he's,
You get over, it don't cost you nothing.
he got a senior.
If you under 27 in here,
25.
well, guys is more.
And if it's red.
That's why I was talking about your break their Swiss card.
Yeah, that's true.
So all of that's more. Mortgages are higher for your generation. Buying a house, say like, even 25 years ago, right? You could buy in a nice neighborhood, a 4-bedroom house, 2.5 bath.
There's some young people in here, and I think that's good because they start.
That house now,
Yeah, I wish I would've.
More than that.
that house, people used to buy condos, 3-bedroom condos.
I take that comment.
3-bedroom condo costs about.
125.
Huh?
125.
Back
Back then.
Oh, back then. But now,
300.
the starting range is below 300. That's the start. Because I paid $390 for mine. I didn't think it was worth it,
Yeah.
but that's what it costs.
Yeah.
I started out to buy because I can't let loose of my money, man. I just said it ain't worth it. But that's what it costs.
Plus interest rates is so high.
So, a guy I know that bought a house 8 years ago, right in Roswell, he paid 1.4 for that house. You know how much his house is worth? 6.2.
5 million.
6.2. But he didn't really sell it, so he could move in a house that costs $1.5 million.
Like knees back.
All right. Up here.
Mortgage is better than rent. It's the same price. Rent is the same price as mortgage.
Not for new buyers. Not for new buyers.
I'm a new buyer, I just closed out.
What was your interest rate?
5.75.
Did you use a preferred lender? It was a new bill?
No.
That's such a low interest rate.
Huh?
Hey, you got such a low, because interest rates start around 7.
Because at that time, it was 6 something, then it dropped to 5 something. I was trying really hard to buy a house in Ackwood.
And they got 5%?
Yeah.
Because most people can't get there.
Yeah,
So,
they were late.
you need to keep your credit
They were
up.
late. I got friends in the real
Don't be
estate.
buying all that stupid stuff on the credit cards to get
Yeah.
kill your credit for buying a house or a car.
They were a
That's why you
lender?
pay so much on the car
So
note,
you have a friend who's a lender?
because your
No,
credit
I
sucks.
went to like.
You can't
6
spend
different banks
over
for the
26% of the value of that credit card, your credit
One
going
place,
down.
like, my credit
It's
was
26, I think, now.
27.
And then,
It's like,
you can't
it's-
have all
it's
of
bad,
them
but it's not
up to
bad.
26%.
But like,
And you better not have filed
Keep on jumping from
bankrupt
banks to
within
banks, somebody-
5 years of trying to
it's
buy a
not working.
property. Cause you
you
ain't
make
gonna get it.
60,000 a year.
And you better not owe no child support, or you ain't gonna get it. And if you're a veteran, they'll even be worse. Because veteran is federal
What lender
loan,
do you use?
child support is federal payment,
I used to
not the
go
government. So that's how they get their money back. They don't get you.
Sigova, okay.
Being a veteran is a detriment.
Huh?
It's a detriment.
I'm a veteran. I bought
You gotta keep on
mine.
trying. Each one denied.
What bill did you put on your credit
And
though?
then like,
Huh?
What bill did you put to your credit card? You know what I'm saying? What bill? You just pay every.
First of all, I don't buy anything
to a new
that is a toy,
After you bought it?
clothes, jewelry,
That's what they do.
none of that, cause that's not necessary. If you're trying to build credit, you better act like you're trying to build credit, cause all them clothes and stuff don't matter. They look at,
Would you put your card note on
I pay cash for my car.
Nice.
there? But I'm just saying, if you had a credit card, would you put your card note on there every month just to pay like?
If I paid it off, they
Yeah.
If you, look here,
Use a
I
credit
use
card?
one credit card to pay all my bills.
Yeah.
I pay it off within 30 days, I pay no interest on that credit card.
That's smart. That raises
But
the
I
score.
do it so I have a record of my spending. I have one credit card that I have vacations on. I only have it for a certain amount so I don't get stupid. And until I pay that credit card off, I don't get to go anywhere. Because that credit card is my only fun activity, credit card. You too stupid to pay it off, you too stupid to go somewhere. I treat myself like that. I don't waste money on anything. Nothing, cause it's not necessary. You don't need that stuff.
Man, you gotta treat yourself.
That's it, run your business.
Well, I am treating myself.
You only live once.
I ain't been in those.
You only live once.
Only what's necessary in life. And then, I'm gonna give you a quiz when I come back. Give me a quiz.
Oh, Lord.
Everybody got stupid Yeah. Yeah, I was gonna say that he got stupid Rex in
He
the
said
back.
he's not even gonna leave the
He got kids about 30 or 30 years under. They got years.
My car note is $480. Yes, it bills me every month and I pay out. My insurance is $483. Yes, that shit kicking my ass. Let me tell y'all, they got a rate.
20 what?
Hold on. I was in a rental car and we was at a light and the girl hit the rental car. Boom. So they put it on my record for like a wreck, but when you pull up the wreck, there's no information on the wreck. So they got my credit skyrocketing out like that. My credit at first I was paying $298. But yes, that should be killing you. Then on top of Atlanta, living in Atlanta, like if you want your own shit, a decent apartment that I found is like $1,095 on top of $480. On top of $483. But insurance, that shit is something. The rent, it was last year in January.
It'd be hard to make that kind
No, when you pull up the rent, there's no information on it.
On your DMV, go to the,
Yeah, I called the people, no, they said, the way that you wrote it up is weird, they said that shouldn't be on your
Because
record.
if it was enough, the rent wasn't enough, she need the rent. She need a police report.
But the rent
The
don't
police
have no
report,
police
she's taking it
report,
back
no.
apart. I'm gonna research that.
Yeah, that shit's insane. 'Cause I need.
You have a police report? Did you get a police report? Yo, did you get a police report?
No, nothing happened.
You should've got a police report, and you can send that to your insurance company, and they will show you what rent was not your fault. They couldn't just raise your limits.
But when the car hit me, I burnt out because I was in rental. I ain't gonna lie.
That's on you.
Years, $200,000-300,000. The young folks can't see like that. Okay. You probably will spend in 30 years on garbage, $300,000, for real.
Yeah, I just spent about $1 million.
You'll spend, now Harrison, I don't do that.
So you don't treat yourself to anything?
I'm sure he do, but the man, he's disciplined. He's disciplined, dog. He's disciplined. That's why he got money on
Well, I don't buy fancy cars because it's a car. You know what a car is to me?
Point A, transportation, point A, point B.
A car to me is a horse. It takes me from place to place. So you can be, now most of us stark rich. Athletes, got no money after 6 years. What you need 5 Maseratis for? You just made the Maserati salesman rich.
Yeah, they didn't do it for the women.
I ain't never had.
Ocho say he's my spirit.
I'm only saying this not to be talking, but a lot of my students want to be in business. How you gonna be in business? Bank not giving no poor person no money. What do you have as an asset against what you're trying to borrow? You think you're gonna walk in there with no money and tell somebody with money how much you wanna, about $300,000? I don't think so. You're getting nothing.
You don't like gas stations and stuff? Like you ever try to open up a gas station?
someone.
Not me, cause here's me, I don't open up no business I don't know, cause it's failing. Well, I gotta pay somebody to run it, they probably stealing my money. So I don't do it, I only do what I do. If you know how to do that, then that's good. If you know how to do it. But I don't know anything about that. I mostly know about machines, commercial refrigeration, air conditioning, and I stay pretty much there. And I had a video camera.
Sound like Warren Buffett.
I've been doing videos since 1972, when we used cameras, you know, film cameras, with Spike Lee.
Spike Lee.
We went to school over there at AU campus at Clark College. Him and my wife was in the same movie making classes. Him, Mars, all of them. Was in the same class.
Oh, they know it, shit, though.
What I'm saying is, all of those people came from the same area. All those people came from the same area. And I'm only saying this because I'm trying to get this test together, is because 50% of my students say they want to go into business, and you don't know what business is. You know why 80% of air conditioning companies fail?
Wow.
Not because they don't know air conditioning, why?
Because they don't know business.
Because they don't know business. And I'm gonna give you something that you can tell they don't. You can go to McDonald's, any of them restaurants, and you see a trade truck, what you see in the windshield?
Their business?
Their office, don't you?
Yeah.
Packed with papers, receipts, they don't even have an office. And this time of the year, for those people, it's the worst time of the year, because what time of the year is this? And they can't prove that what they spent, what they made. So they're ready to get slammed and put out of business. Accountants charge you $300 an hour to take that paper bag of invoices and put them in order. Then in order to put it on a spreadsheet, they charge you another $475 an hour to file your taxes. What you got left? Then you gotta have medical, don't you? Because you in business for yourself. Medical could be, for us, $1,000, $1,500 a month for a family. They call a family one person behind you. That's a family. And so you have to have that money, you have to have vehicles, and you have to have people that are qualified to do what you want. And the biggest thing is, that's why I go over this, because you have to be able to do what you say you can do. Or you make no money at all. So you better be serious about your approach to this. People who aren't, I've had several students that got businesses and make money. Not a whole lot of them, but it is true. And they make money. So you can't take a piece of this, not ask questions, and not try to understand it. It's a very highly competitive business when you get out of here. But you can make money. Because you can always find your niche. I did bars and restaurants. That's what I did. Small bars and small restaurants. And I kept working and made a lot of money. I didn't try to do brokers and them people. That's not my lane. Stay in your lane. Made a whole lot of money. Didn't need a whole lot of workers. You can fix most of it with yourself, and you can make money. But you gotta know what you say you know. And it keeps changing and evolving. That's why I talked about digital from analytical, and it's gonna keep changing as we start talking about some of these motors. And I'm gonna give you this take-home test. And did you ever get a syllabi in this room?
Yeah.
Where do you see it? Syllabus.
Yeah, we didn't get
Syllabus. All right, let me see now.
It outlines everything.
It
outlines everything.
Most of the things we cover is not in. But it does outline, you got to stay on some track. You already got your
Oh, we talking about
midterm is in 8 weeks. Basic magnetism, we kind of been drilling that. Automatic controls, automatic control components, and that'll probably be next. Cause I know you didn't do automatic controls on 14, did you? So we'll probably do automatic controls and 13 and 14. Introduction to automatic controls and automatic controls, what that means. Automatic means I don't have my hands on it. Analog is even touching the thermostat. We have systems that you can take.
I never had a syllabus.
You can take your cell phone and turn on these systems. You can take a laptop or handheld, and I can operate a refrigerator container when it leaves China till it pulls up in Savannah. Monitor the temperature. That's where you are now, that's where we've been, but that's where you're gonna be if you choose to go at that level. That's what automatic controls are. We don't operate buildings, we'll be talking about BAS, building automation systems. It's hands off. So all the buildings downtown, the stadium, any high rise, all these malls, you ever wonder how they cool and heat? You probably did, didn't you?
Yeah.
So how does a technician know the airport? All of these places, you have to have a way of viewing the performance of the machine. And that's what automatic controls, building management. We have, remember we talked a little bit about sensors, right? A sensor, we will. A sensor does what? Measures something. We talked about that Fred Flintstone pressure control with a sensor. We talked about a thermostatic valve with a sensor. We will talk about digital sensors are thermistors, but they read something. I measure something and I produce a result that connects to the programming on a board that opens and closes switches that allow a machine to operate under the conditions that I want it to. 7 days a week, every other day, when people are not having activities in that Mercedes Stadium, do you think they're cranking that air to 70? Oh no! It'd probably be about $5,000 a day with nobody in there. So we'll run it to 79 unoccupied. And we can tell it when to come on. So if it's a conference or an activity or a game, games maybe start at what? I don't know, 3:30, 5:30, 7:30. It's always something weird like that, depending on if it's on a weekend. And you 5 hours before you crank up the machine, you can crank it up at home. We always have 5 technicians on site. So you go to work, you be there on the job at 5:30, make sure there's no leaks from the ceiling, any of this kind of stuff coming from the HVAC. And we operate it, but we can tell, you can tell what the temperatures are at every coil, every unit, every condenser, and the temperatures in each zone can be verified, altered, or identified for service. That's what controls are now. Equipment is so mammoth. You can't go around and say the air handler up in there. It's identified in the software. Air handler number 13 is located in room 311 location with a little drawing. Second door, 8 tiles over. 8 ceiling tiles over. It's right up there. And now we put tags, stick-em tags like ushers wear. We have them stuck on these. And so you can see air handler unit number. Look at your laptop and you can open up the building, connecting to the building's computer for air conditioning. Air conditioning has its own computer. And we connect to that computer and we can look at this room and we can toggle back and forth and make the system operate or troubleshoot it through software, and then it'll tell us if the filter's dirty. It'll say change filter. That's why the temperatures are rising, or if it's too much dirt in the filter during heating, it'll overheat and a limit will take it out. If it's too much debris in the filter during cooling, it'll freeze up, ice up, and you won't have cooling, and it'll cause water damage and leaks. So we're doing this, understanding at the beginning that controls are analog, click, click, click. But it still does, what did I say it only does? With all of that, hitting the computer, take me to room 339, show me air handler unit number 7, show me, and it'll show you a picture of it too. And it'll look just like it looks in a drawing, but a very realistic AI type of drawing, you know. It's really a beautiful piece, and we probably pay $150,000 a year for an access key for our companies to be able to utilize the software, and then they maintain it. And so when you look at these machines, you can troubleshoot it better. The service manager in the office can see it too. I had about 6 screens that size. We had 187 buildings. You could go to any of them. I could see if I wanted to, I could make them like that. Put about 12 buildings on a screen. And then it'll make a pie diagram of temperature from red to yellow to blue. If it's in yellow, what does that mean? Cool. If it's in green, what is that? That's where you want it. Yellow means we kind of leaving a little bit, set point, kind of drifting. Red means that baby's off. So when the service person gets his tickets, this is how automation works. You're gonna see that red on there, that's your first drop calls. Because in commercial, you can have a 50-ton unit on that wall that's blowing through duct, controlling 60 rooms. So you don't get so excited if they say, hey, you got 60 service calls this morning. I'm gonna look on the computer and say, how can I have 60 service calls? And I'm gonna look, and if it's that one machine, that's the machine that has 60 units down, and that's the problem. So then you can troubleshoot it also with the machine. You learn how to use the machine. The machine troubleshoots the machine. That's how it works. So you'll be sent to extra schools for this, the ones who are the brightest. You choose if you want to be the brightest. Some people are happy with AI. And you can go to these schools and learn how to operate it. And once you really kind of learn that type of technology, I haven't met too many people that ever want to go back down, because it's a whole different world. Because now you won't be responsible. We give each tech maybe 10 buildings, huge buildings. That's your building. You get a helper. Other people will help you if you need help. So if you're the supervisor, you're supervising the 37 techs that run service calls on 187 buildings, along with 13 outside contractors that we hire, because sometimes we don't have our guys changing big giant compressors as big as Volkswagens. We hire that out to McKinney, Train. Everybody does. If Train build it, we're gonna give it to Train. Why?
They know about it.
Because they got the parts. And they save so many parts back for their customers, for their customers. So if I say, hey man, you got a flywheel off of that centrifugal chiller, nah, yes, we can't get one of them for about 13 weeks. So you call their service, yeah, we got one. So you're gonna let them put it in, because it has to be in. They have also the access to the engineers that design those machines. Yeah, what?
Their tests, their quiz.
No.
Oh.
Well, we got some bad.
No, I was just on the part with the quiz while you did this time.
Oh, it's time? All right, let me,
It's approved.
all right.
Well, I don't know if it's approved.
Oh,
He put it in.
Hey,
Y'all ready for your quiz?
The take-home test.
Huh?
He said the take-home
It's
test.
gonna be a take-home?
Yeah.
Open
I'm
book?
so disappointed. Open book.
Yeah, that one you just literally just said.
Open book.
What kind of test is that?
You sound disappointed.
We
Dr. You take home test?
Yeah.
Oh, now let's close the books right now. Let's go. No.
Oh, yeah, you did.
No. Let's take this right now. R-A-T Where you coming from?
Okay, Universal Studios.
When I work out,
Is that like
I always do the
school?
treadmill first.
Yeah, I think that's it.
I
I
do
don't
the
know.
steps. I do the steps.
You know how to swim?
So, Sunday is my birthday, hint, and, lamb, medium.
Wait, hold on, let's say.
That's
Stop,
right.
let me stop you for a second. You told us you don't like us.
That's true, but, you know, one day I let it slide, that's on the birthday on it.
So you still want us to bring
You know, Monday is good, you know, since everybody be here at one time, right? Right. You know I still got the grades, right?
So what, so.
This bitch, this room for about 5
It's in my
minutes.
grade book.
So we bring you something for a gift, that's what you look for you.
Yes, lamb especially.
Not bringing that.
Bring you a pack of cigarettes.
It's very relaxing. Yeah.
I don't like the texture of lamb.
You manage space. And it goes more than that. Telephones were made in Asia. Your television came from Asia. I don't care whose name is on it. Because guess what? It's this thing. And what did I say they manage? Space. So your TV don't have a big booty on it no more. It's like this. First it went like this, and it was on a big box from San Souci. And then it went like this. Now they're like this. They go curve. Got all that in.
Now they're projecting.
Projectors been out for a
I
while,
mean, been
but
out
they're
for a
better.
while. Yeah.
But they're
I
better.
was gonna say,
Because the first projections, they was like kind of cool, but you know, it was kind of dull. You couldn't have that much light coming in. But now it's like a television. I could fill that wall up with my little projector, and they used to be this big, mine is this big. It don't cost that much either. I'll spend money on that. On electronic stuff.
They good in the basement.
And cooking supplies like I got a bread machine. I have a air fryer combination, oven, slice, microwave. I get them off QVC. You know QVC got everything. And they guarantee it. They don't care. They'll send you another one. Don't even want the one you have. They don't want. So I get stuff from QVC. I got a real space age coffee maker. I will spend money on gadgets that I use. And I grind my own coffee beans.
A car, yeah.
I don't drink coffee that's already grinded. I grind my own. I go to the farmer's market and get organic coffee beans and grind them. I don't eat fish that come wild caught. I don't eat fish that come out of a fish farm. You know what a fish farm is?
Yeah, where they grow fish.
They can't grow a fish, right? But it'll be an aquarium the size and the depth of this room. And if they're growing, I said it again like you did. If they're raising, tilapia is one of the real ones. They might put a pool out in the backyard and do tilapia like a plant. And there might be, in a room this big, if you had salmon, you know how big salmon get, right? Mm-hmm. It might be 4,000 in this area, just like this, swimming past each other. And then when they get a different length, they put them in another tank. Then they get a different, and did you know that's how they raise chickens?
No, everything's like that. I got chickens.
They treat them real nice when they little. Be with a little light in there, and they be with big heads and big eyes. And when that sucker starts standing up, cheeping a little bit, and got yellow, go to another cage. And then when he turn white feathers, not feathers, but get the white fuzz, he
go through another cage. When he get in that other cage, he start growing feathers, and it's about that tall. And when his head touches the top of that box, he go through the last stage. And I'm not kidding. I wouldn't want to be a chicken, because every culture in the world eats you. Nobody don't eat chicken. Chicken got the shortest life of any animal. The shortest life.
700 million, I wanna say they consume a year, 700 billion.
But when they get sick, you gotta kill your whole farm.
No, it's separated. Yeah, the bird.
If you get bird disease, you gotta kill all of them on the whole farm.
Oh, yeah, but they all be so close, they locked it,
They stack them on
stack them all
cages,
together.
and it's so cruel. It tastes good fried though. But I had a classmate that was an All-American defensive tackle for Ohio State. His father, he came from a small town in Ohio. So you don't know, Ohio got a lot of farms, just like Georgia. He came from a town called Chillicothe. It's a chicken agriculture place. His father owned a huge chicken farm. And this dude was like 6'8", 270. He didn't eat meat. He only ate right, because they had a farm. He ate the right stuff, and he was huge, and he was a beast. So he worked in that farm because he was really family oriented, helped his daddy, and he didn't come back his junior year. Everybody's like, "Where's Jimmy?" And he said he got sick on that chicken farm. I was like, "How?" And his father didn't have enough ventilation, because he enlarged the chicken farm and didn't enlarge. That's what we do. HVAC is what? Heating, air conditioning, ventilation. That's what that is. And we also do ventilation. And so he was breathing chicken crap that has what in it? You ever been in one? Ammonia. And you can smell it good. Yeah. Toxic. And it gave him some kind of bacteria disease on his lungs. And then he came back to school just to visit the team. Like 8 months later, he was your size. We didn't even know that was Jeter. I was like, man, that? They said, that's Jeter. That ain't no Jeter. And you look at his eyes, you can tell. And then 6 months later, he died from chicken disease, from breathing that and got in his lungs.
No, he did, no man.
I don't know. You know, back then, people didn't wear no masks. They just worked. We worked in factories. I worked in Chrysler, worked in Ford, Firestone Tire, Victory Battery, made everybody's batteries, and they had no air conditioning in there. It would be boiling steel. You put it in this hopper, and they boil it till it turn orange like Kool-Aid. And you know how hot it'd have to be to take a big iron piece of steel and do it. And they would pour it in there in these molds and make transmission cases. You know how your transmission got that case, engine housing that you build the engine with? That's what we made. It'd be so hot in there, and them old guys, I was like 20. I wanted to make that money, like y'all do. They were paying good money. And I saw them old dudes with all that stuff on them. I was like, what's that? They had this big hopper that was probably big as a van. And it was on these big rails that would go from one side of the factory to the other one up in the air. And sometimes the kettle spilled a little bit, and it would bounce off the floor and get on people. And the big quarter-sized burns deep in their skin.
The next 60 seconds, I'm gonna show you how to
I can't do this. I think I'm going to college. I can't do this. I don't care how much money you make. So that part, things changed. And because it was so much like that, I grew up in an area that they called Steel Valley. Because anything was made on a car, a chassis, anything. We made the molds, burned down the iron, and made cast and made it. And I'm gonna tell you, 19, it's gonna be old for y'all. But in 1972, that's when I got out of high school, you could work in Dana, corporation with that steel, 50 grand in 1972. 50 grand. So you could imagine when I moved, I thought they was crazy here. I said, what? What? Sarah said, we're paying you $16 an hour. We ain't never paid that body that much. I said, you ain't gonna pay me that either. I was like, nah. And so it was Indiana, Michigan, Ohio, and Pennsylvania. That was Steel Valley. Got out of high school, went in the factory. Everybody needed it. They got married, the wife worked in a factory, they work in a factory, they bringing $100 grand home, 20 years old. I'm in here college carrying books, and I come home and like, shoot, I want me a wife and some babies in a house. Everybody else got a wife, some baby in a house, and cars, and we the same age. And then they pulled them factories out, and they started selling it to first Japan, because they'll take those cars that's in the junkyard, they'll cut that, you ever seen them cut that metal up? Look like cereal. They cut it up and look like cereal. That's small, whole car. And then they melt it down to that steel, I'm telling you, and remake something else out of it. They could do that cheaper than building it here. Paying for it over, paying for it to come back. And so that's commerce. So that area just dropped, man, because it was iron, you know, all that. And then it controlled certain economies for certain cultures, right? Because you know who worked in the factory. Right? So it empowered you to buy homes, have family, for fathers and mothers to stay with their children because they didn't have financial problems. They were happy. They're buying 2 cars and all that. Going on vacation and it's too much living here.
The government looked at it.
We gonna send this over there. Y'all gonna get back on that ranch and do what you've been doing. You're making too much money. So they force people for education, which is a good thing. And it was always pushing teachers, and you can always make money any generation getting a 4-year degree in accounting or marketing. You will always work, because every businesses need what? Accountants. You can work anywhere in the country and do any of this work. So it wouldn't help you to have some kind of accounting background before you go into business, because everybody you have to pay to do something for you is less money you bring through the door. So you might think bringing in the door $100,000 a month is a lot of money, but not really, because you have to pay your workers, office, truck, insurance, Department of Labor. You have to pay all of that, your taxes, your accountant, and then you pay your building, you leasing, and then pay you. And then keep your house up. So you need probably, living a moderate life, probably about 300, 400 grand a month of business. Not in your pocket, but of business in order to live the lifestyle that most of y'all want to live. That's the reality. That's the reality. Then you have to plan for a rainy day. Like COVID. Who could plan for COVID?
Right. None of us.
Nobody. And then you just doing like y'all, you done spend all your money. Do it up in the air. Got 5 diamonds on your ear. 6 diamonds in your nose. 5 diamonds in your tongue. Some diamond bracelets in your teeth. Now you got no money. Take that home, complete it.
We done.
Well, y'all ain't done with that. Give it to me.
I'm not done. No, I ain't done.
We done.
We're done.
Great things today. You better be done with that.
100.
I'll take it home.
Yeah. Take it home, get it.
Y'all give the test
If you
y'all
take
did.
it home to complete it, the best you can get is a 70.
Oh, no.
Oh, yeah.